Hello everyone, welcome to the channel Code Like Him. Guys, if you find this video helpful, please like this video and subscribe to the channel. Now let's see today's problem. Length of longest cycle in a graph. Given a directed graph with v vertices numbered from 0 to v minus 1 and e edges represented as 2D integer 2D array edges, where the edges of I is equals to uv denotes an edge between the u and the v. Each node has at most one outgoing edge. This is important. We have at most one outgoing edge from a node. Your task is to find the length of the longest cycle present in the graph. If no cycle exists, return -1. A cycle is a path that starts and ends at the same vertex. So let's see the graph here. So if we start from the 0, we will move to 5, we will move to 6, 3, 1, and then again 0. So this is a cycle, and the number of nodes are 1, 2, 3, 4, 5, 5. So we need to return the length of the longest cycle. So the output will be 5 here. If we don't have any cycle, we will return -1. So this is similar question where we need to detect the cycle in a graph, directed graph, which was done using BFS or DFS we can use. So this is the same approach we follow, we will follow, and also we need to return the length of the longest cycle. So in this we will gonna have a vector count here, which will tell us that how many nodes we have visited so far. For example, if we are standing at 5, we will be saying we have 2 nodes because 0 to 5 we have visited 2 nodes. At 6 we have visited 3 nodes. At 1 we have visited 1, 2, 3, 4, 5 nodes. And then we will check 0. We have already visited 0, and the current node 1 have 5, value is 5. So we're gonna subtract this 5 minus 1, that will give 4, and we will add 1 to the result, that's give us 5. So that's how we're gonna have this answer 5. So let's look at the code here. We will have this e, because at most we have one outgoing edge. So this e is what is edges. So it's gonna have the current, the u and the v, from which a node to have we have as to that node, and we're gonna initialize as to -1. We have visited array in recursion because we need to check if we have if the current node is in a cycle or not. We're gonna require this in recursion. And the count as described in the approach here, we're gonna have this count vector which was initialized to 1. So we're gonna iterate over this the number of edges v till if we have not visited it. We're gonna call the DFS, and in the end we're gonna return this res. So in the DFS we will just mark the current node as true, visited true, and in recursion true. In recursion is required because we need to find out if the current node is a part of in recursion, then we're gonna just set this in recursion true. We got v equals to e of u. So this is the directed node from the node v. It can be -1. So if it is equals to -1, we're gonna set in recursion false and just return it. We will check if we have visited the current node or not. If we have not visited, we're gonna increment the count by count of u plus 1, because let's see, if we have at 6, we're gonna have the count of 5 plus 1. Simply like simple logic, and we're gonna call recursion for v. If we have visited, then we're gonna check if that node is in recursion or not. If it is in recursion, it means this is a cycle. So the cycles maximum number of nodes will be as described in the approach, count of v minus count of u plus 1. Let's say if we had at 1, we will be having count of 1 equals to 5, and count of 0 is 1. 5 minus 1 equals to 4, but we need 5, so we will increment by 1. And in the end we're gonna just make in recursion of u is equals to false. So this is a simple DFS solution. Time complexity will be big often because we are using the type of search, and the space and it will be auxiliary space of DFS. So guys, if you find this video helpful, please like this video and subscribe to the channel. Thank you.